Hello and good morning. Um, Thank you to everyone who has woken up early on a Saturday morning at the end of school week. Sorry, a bit of echo. Okay, that should be the audio sorted out now. So, first of all, if there is anybody who is somehow in the middle of invigilating APMOPS, please do your job properly. Um, you're supposed to be taking care of primary school kids. Please do your job properly. Make sure nobody cheats and nobody uses ChatGPT. Uh, for everyone else who is here, then once again, welcome. We are going to probably spend around the 2.5 hours looking at the questions of my HARDSMO Junior Round 1. And we are also going to just talk through some of the considerations, logistics, strategies, um, psychological coping mechanisms, and all of that as we go through the paper. Now, this will also be available on playback. So if anybody at some point needs to leave, don't worry. The recording will be available on the YouTube channel page together with all the live from the past year assembles. Now, we are going to start off with the thing that everybody is going to ask about. Either you are asking it in the chat in a few seconds' time, or you are intending to ask it at some point. So, what are the cutoffs? I have gotten a fair number of responses. I know that some of the responses are repeated, some of the responses are you tried multiple times, some of the responses are you're just checking one question, some of the responses are from those who are doing senior or open but just wanted to try the paper. So I did go through the data, it is not just a raw average. So I can review what I think would be somewhat realistic estimated cutoffs, which would just be as follows. Okay, so this is uh, impossible to ascertain because the SMO does not have a fixed cutoff score, neither does it have a fixed cutoff percentage. Okay, this is the SMO Junior review video. Hard SMO, but it's for junior. So I should just say, in case any of you have been told by your school teachers otherwise, the SMS website currently still says that the number of people who are getting into the SMO for round two is going to be somewhere around the top 10%. Right? This is in the website. Let me show you what it says there. This is the SMS website. And it says that participants in the top 10% of round one of the competition will be invited to participate in round two. This is also probably in the registration form that you have gotten from your school. It says that the top 10% will be invited to participate in round two. This is wrong. This is not my opinion. This is just factually wrong. Now, this is factually wrong because in the SMO recently, your junior has about, I think, 4 to 5K participants, and only about 100 get into round two. So obviously, that's not 10%. So I have to say this because some of you are obviously aiming for round two and maybe you have heard from your school teachers that it's top 10%, and then you're thinking of, hey, top 10% doesn't sound so bad. Well, it is, top 10% is not so bad, but top 10% is going to be probably somewhere about here, from like the bronze to silver is actually where the top 10% truly is. So therefore, getting into round 2 is pretty hard. Now, another thing is just that for those of you who are like, I want to get a gold. Gold is based on round 2 and round 1 put together, which means that for round 1, you are not able to talk about what is a gold cutoff, right? No such thing. You just need to get into round 2. If you get into round 2, it means that you are guaranteed a silver. That is, well, a motivation that if you get into round 2, great, but just in case you miss by a little bit, do not get too discouraged. If you happen to miss round 2 by a couple of points, that is still going to be a silver, which is really good for almost every one of us. We would be quite happy with that result. All right, now I'll say a bit more about like the cutoffs as we go along, but I will just say, since you're here, that last year cutoff would be approximately 2 points more than this. So in other words, I am estimating that my paper is around 2 points harder than the SMO's paper from last year, which is of course entirely subjective metric, but I have my reasons, and I'm sure that as most of you have indicated in the paper, this is a hard SMO. Now, I'm going to go through all the reasons why it seemed hard, because I think this is a useful exercise. The actual SMO is unlikely to be hard in all of these ways, but the actual SMO is often going to be hard in one or more of these ways. So, firstly, actually, I'll just show you a bit. All right. So, firstly, the hard SMO seems hard because the easy questions are not that easy looking. The SMO has easier and harder questions. They are not perfectly in order of difficulty. That is never the promise that the SMO makes. It's not in the official rules. It's just you can kind of tell it more or less increases, but it is not perfectly increasing. So when you're doing the SMO Junior, especially if you are Sec 1 and you're doing it for the first time, you will see a lot of algebra, which means that, let's say, something like your first couple of questions, maybe turn to that. Yeah. So something like this can look a bit scary if you're doing SMO for the first time. Now, this is supposed to be the easy questions because they are aligned with your school syllabus, but not Sec 1 school syllabus, right? SMO Junior is for Sec 1 and Sec 2. So if you're a Sec 1 student, then something in Sec 2 math may feel difficult to you. But these are part of how the SMO is like. By now, you wouldn't really be able to say that I'm going to study 10 different topics I've not learned before. But just be aware, right, that sometimes things seem difficult, but it's because it's Sec 2 math. Now, there are some questions which don't have an obvious method, but are actually quite easy. Meaning that for some of these questions, almost everyone who answered the question got it right. It's just that a lot of people left it blank. There are also some questions that just look scary. Now, they are made to look very intimidating or very long-winded or very just weird. And that's related to some of them sounding confusing. Now, I will say that for things that sound confusing and things that look scary, remember that 2.5 hours is a lot. 2.5 hours is a lot for junior. Those of you who are in my classes, you know that I always say, has anyone actually run out of time before on the SMO Junior when you are doing it continuously for 2.5 hours? The answer is usually no, meaning that you run out of ideas. Or maybe after like 1.5 hours, you take a lot of time, you can't solve anything. Then the last 3 minutes, you suddenly notice something and you're like, oh no, I can't finish that last question that I suddenly figured out. Well, that is the only sense that you run out of time. But it means that the confusing looking, the scary looking, just take a deep breath, just slowly look at the question again. Do not skip a question just because it sounds confusing. Now, of course, this is with the caveat that if it really seems that the question has something wrong, please raise your hand, ask your teacher, and your teacher will send a query to the SMO organizers. If there is really an issue with the question, you will probably get an announcement like half an hour later or something like that. Now, another thing that people say is that, oh, geometry is hard. Geometry in SMO is one of those things that a lot of people find difficult because geometry in school is too easy. That's borderline insulting, but it is kind of true that everything in school math for geometry tends to be on the obvious side. So we'll see a few of the geometry questions later with a bit of different ideas. And also, most of the questions cannot be guessed. If you are looking at the SMO, there is no penalty for guesses. So please do guess. Okay, some of you left a lot of questions blank in your submission. Maybe you just think that it's a mock paper, so don't need to guess lah. Or maybe you thought that I would actually be reading the solution and you don't want to look silly. Well, in the actual SMO, please guess. But I have also made the paper such that it is quite difficult to guess the correct answers. Okay, so it is quite tricky to get the more than one question guessed right, I think, based on this. Apart from the multiple choice, if you guess all the multiple choice, then of course, on average, you will get one right, but I hope you didn't guess all the multiple choice. Now, one more thing is just that today I'm doing a marathon series of live streams, so I'm doing junior, senior, and open. The junior paper, out of the 3 papers, is supposed to, of course, be the least scary looking, right? I mean, it's in that order. But there are those of you who are aiming for a gold, you're aiming for top 30. And then you looked at the paper and it seemed not so bad. But then bad things happen, right? In the form, I asked you guys to key in your expected score also before you submitted it, right? I want this because a lot of you, 2 reasons. Firstly, overestimate your own score, and therefore you think that, oh, I have solved everything, then the last 30 minutes you just sort of just relax and chill. Do check your answers. Do try to actually use your entire time to maximize every point you can get. Secondly is that you will find that after the SMO, your friends will come out and say that they got very unrealistically high scores, and then you will feel a bit depressed. And then after that, in the afternoon when I do my SMO live review on the same day, then suddenly in the chat, everyone will sound very depressed, right? So after the SMO, everyone sounds very confident. How come like 6 hours later, everyone sounds very depressed? Because the truth is that on this paper, basically, I can say that the actual score was around the expected score minus 20%. That was on the average percentage loss of points was around 20%. Now, of course, I know that some of you guys troll me by just keying in the expected score is 25 or your expected score is 0. I do discard those. I cannot be sure that everyone is giving a serious expected score, but this is not so much for me. Actually, this is for you. Right? I want you to realize that this paper has a lot of questions where I know what is the likely mistake, And indeed, the likely mistake actually happened. So we'll talk about those as well. But right off the bat, I'll just say that when you look at the question, you should think about two things. First of all, you should think about your strategy to solve the question. And second of all, you should already start thinking of what are the sort of traps, what are the sort of like careless mistakes, what are the sort of uh, hazards that I need to avoid. Okay, so this is just an intro to acknowledge that yes, the paper is hard, but there are many different aspects of hard, and you will find that a lot of the SMOs, the different years, have different aspects of hard. Some of the years of the SMO just look scary only, but actually it's not very hard in terms of the actual difficulty. Some of the years of the SMO are hard because they're full of traps, but the questions don't look difficult. Some of the years are just full of algebra, which means that if you are transitioning from the SMOPS, APMOPS, which is going on, I think, right now, to go to the SMO Junior, it seems a lot more difficult, right? So that's also another reason. All right, so I think you are waiting for me to go through the questions. So I am now going to talk about the actual problems. So here we go. Okay, question 1. Before I say it, just do take note that question 1 is not always going to be the easiest question. There is no guarantee of that. If question 1 just frightens you, feel free to just skip question 1, come back to it later. All the questions are worth 1 mark, yes. So full marks is 25, every question is worth 1 mark, there are no negative marking, so you should guess as mentioned, whether it be multiple choice or whether it be the short answer questions. Okay, question 1 in this case here is probably meant to be the least difficult question, and based on the scoring, almost everyone who attempted question 1 managed to get it right. Answer is A. Now, all of these numbers are 10, 100, 1000, 10,000, 100,000. So therefore, when you put it to a power of something, you are just counting how many zeros are there at the back, right? So the number of zeros behind, right, would be 6 factorial zeros. 100 has 2 zeros, then times 5 factorial, and so on for the rest. It should be pretty obvious that either by direct calculation or just common sense, that this 6 factorial is bigger than all the rest. 6 factorial being 720 is a lot more than the others. Okay, so the greatest number of zeros is the largest number. For questions on which of the following is the largest, the smallest, very common in SMO Junior multiple choice, there are two broad options. One is compare them two at a time and then eliminate. The other is compare everything if they are all of the same type. Okay, so just look at them, do they seem like the same type? Here they're all the same type, which is 1 followed by a bunch of zeros, so I can kind of compare them all together in the same way. Okay, question 2, right? Thanks to the person who commented and told me that the question originally looked a bit confusing because it was like the n cubed looking thing here. So I added the dot. Anyway, if that was really n cubed, it would be none of the above. So then you know that something has been messed up. Okay, so let n be a positive real number. Which of the following is equal to this? So this is just the rules of indices and surds. When it comes to the rules of indices and surds, just understand that your surds are also fractional exponents. Right? If you have got the nth root of x, that is x to the 1 over n. If you have the nth root of x to the power of m, then x to the m over n. Therefore, what I'll do is just to go from right to left, basically from inside to out, and I will convert everything to fractional exponents. Okay, so first of all, n root n, which is the innermost layer, is n times n to the 1/2, so that is n to the 3/2. Right, 1 plus half is 3 over 2. Then I cube root it. So the cube root means divide it by 3, so you're left with 1 over 2. Then you multiply by n again, so you end up back with n to the 3 over 2. And then you take the fourth root of it, which means you divide it by 4 again, and you end up with n to the 3 over 8. Now, although it is not very necessary for this question, one of the tricks for SMO multiple choice is that if they are asking you something and you see that it is in terms of x, in terms of n, you can always check your answer by substituting in some value of n itself that helps you to see. So for example, because here all of the denominators 8, 12, and 24, you know that a good choice could be to, right, so to check your answer, you can let n be, let's say, some nice power, like 10 to the power 24, maybe, if you just like that, and then just compute what it is equal to and then match it. So sometimes you feel more comfortable working in that way because, oh, I can square root 10 to the 24, I can cube root, I can fourth root, so that it feels a bit less scary than fractional exponents. If you found that's helpful, then you can do that. But otherwise, I think question 2 was also pretty well done. Okay, question 3. The numbers 1 to 120 are written on cards and placed into a bag. Mike picks a card at random. Let the number written on it be n. So n is not decided before the question, right? N is decided from the card that Mike picks at random. So basically, it just means Mike gets a random number from 1 to 120. He now takes all the cards out and subtracts n over 2 from each number. Meaning that literally, your cards now contain this the second time. Now, the question is, what is the probability that the number on Mike's card is n again? Now, it says it's n again. It is not that, oh, I need to just therefore pick that one specific card. That's not correct, because it is possible that the card with the number n does not exist after you've done the subtraction. In fact, what we can say is that for n to be on a card the second time, it means that the card originally was n plus n over 2. So the card was originally 3n over 2, means that 3n over 2 needs to be a number on a card, right? You can't have said that, oh, if n was 120, There was no card that originally had 180. Now, if n was 1, there is no card that was originally 3 over 2. So therefore, what you actually need to have is that 3n over 2 as well as n are in the list 1 to 120. Now, this is a slightly long-winded way of putting it because I'm sure some of you immediately realize what's going on. I'm just trying to mention it in the most foolproof way possible where we know that we didn't miss out anything. Okay, so two things must happen. For 3n over 2 to be in this list, it means that n must be even, and 3n over 2 has to be at most 120, so n is at most 80. Now, if n is at most 80, that means that your n can be any even number, which is 40 of the choices. So therefore, your first random number, there is a 40 over 120, or 1/3 chance. And then the second time you take it, you still must make sure that you really get this number. So that is 1 over 360. Okay, question 4. Now this is the scary looking one. Y equals to, what in the world is that? Cube root of square root of x squared plus 1 plus x minus cube root of square root of x squared plus 1 minus x. Which of the following is equal to x? And then you have a bunch of options which all look equally complicated. But among the bunch of options that all look equally complicated, one of the things which I can observe is that the list of things here, all of them involve a y cubed, right? So multiple choice strategies also include, like, you can use the options to give yourself a bit of a hint. So it means that, okay, it probably requires me to consider y cubed. But I don't really feel like cubing this thing is like so ugly. Okay, so let's not exactly cube the thing. So the sweet spot when you're doing SMO, right, is that you should be willing to do very horrible looking things. Willing, but reluctant. Meaning that before you do the horrible looking thing, you ask whether, is there a way to make things nicer? There's always two types of mistakes that some of you make. One is that you are, anything that sounds a bit scary, don't do. Then end up you cannot solve most of the questions because you dare not touch them. The other side is, I am very desperate to do well in SMO. I want to win. I want to beat my friend. And therefore, I am going to do, no matter how horrible it is. But then the thing you did was really so horrible that you just kept on making mistakes everywhere. That's also bad. So the in-between here is that, yes, I want to cube it. But no, I'm not going to cube it that way. I am going to instead just call these two things A and B. So if I'm going to cube this, it means that A minus B cubed, which is y cubed, I can just use my cube identity to say this. Okay, so I'm just leaving it like that first. Now, of course, I know what a cubed is, and I know what b cubed is. It's just get rid of the outer scary looking cube root. Get rid of the ugly scary looking cube root means that, okay, so therefore a cubed minus b cubed is equal to 2x, right? That is two of the terms. At the same time, these are conjugates because of the plus and minus. Conjugates means that whenever you have two things involving a square root and then one is plus, one is minus, we are happy to multiply them as squared because of the difference of squares. A cubed b cubed is what? So therefore, of course, AB itself is also what? That means that I can simplify this a cubed minus b cubed is 2x, but the other part of it, if I just factor out AB, so I can factor out the 3 as well, so maybe I should do that. I realized that, oh, so therefore, it's just negative a plus b is negative y. So that is my equation, and immediately I can say that x is equal to y cubed plus 3y over 2. Okay, so this is probably the least ugly way to do question number 4. Okay, last multiple choice, question number 5. This is very deceptive. It is not objectively very hard. Neither is it very easy. It is just that I think it has one of the highest error rates because the correct answer is E, but there are a lot of people who put C and D. Now, this is one of the things that appears a lot in the SMO Junior style of question, right? Which is questions that are borderline logic sounding. It also sounds like, oh, you're just doing listing. But then it's not the kind of listing where you can say, I do systematic listing, because what is the system? And how do I know that I have found everything? Now, this is also the sort of question which is one step away from being a round 2 question. If I change 4 distinct lines to 5 distinct lines, I think it can already be a round 2 question. In the sense that for you to prove that your answer is correct is also part of the score if it were a round 2 question, right? Of course, you don't have to do that for round 1. Now, nonetheless, a useful strategy for many of these questions to check your answer is to try to find a justification for your answer. And if you cannot find a justification, then that's a warning that maybe I am wrong. This will also recur in 1 or 2 of the later questions. Before we start drawing, what's the maximum number of right-angled triangles you can have? The answer is 4, because it is 4 through 3. Literally, I'm saying the maximum number of triangles, not even right-angled triangles, right? Because triangles are literally 3 lines out of 4. In order to form a triangle, you need 3 lines. So 4 through 3, which is just 4, tells you that, okay, now that I know the maximum is 4, my to-do list is try my best to get as many of 0, 1, 2, 3, 4 as possible for my x. I think that if you just start drawing, some of these will be pretty easy. So for example, 0, I can just draw an asterisk like this. There's no triangles at all, so obviously there are no right-angled triangles. If I want to add one triangle that is right triangle, I can always just say, okay, fine. I will draw one right-angled triangle, and then I will just draw it like this. Okay, so this obviously only has one triangle. If I want to have two right-angled triangles, then I just have one on each side. Okay, those two look like they are almost perpendicular to each other, so let me draw a slightly different direction of line. But basically, yeah, maybe this is just the more straightforward way to have no issue. So there are two right-angled triangles. If I want it to be x equals to 3, I can turn this angle here into a right angle as well. Remember that these triangles here also count. And finally, if I want x equals to 4, then I should draw two pairs of right-angled lines, perpendicular lines, I mean. And so in this case, I have got 1, 2, 3, and 4. Okay, so this is everything. I find that one of the funny things about this question, which was partially intended, is that it almost seems like the more experienced students had a higher chance of getting it wrong, because for whoever was thinking that they had a proof or thinking that they had a justification, but the justification was wrong, that would lead to, like, oh, for example, I can prove that there's at most 4 and the number of right-angled triangles must be even by symmetry. That's not true, because you may have made some sort of pseudo proof. Okay, but otherwise, this is the multiple choice section. We have 5 questions here. I think that out of the 5 questions, it is quite possible to get at least 3 of them, maybe 4. Question 4 is the one that looks scary, and question 5 is the one that is easy to mess up. Okay, so by the way, just something I'm going to do a bit for the purpose of making my handwriting not so bad. I realized that Microsoft Word lacks like when I do a lot of writing, and it sort of needs me to refresh it. So every 5 questions, I'm just going to refresh Microsoft Word, and that will tend to make the thing look a little bit better. Okay, so yeah, I think we'll go up to question 9 or 10 before we take our first intermission. Right? We'll probably break it into 3 parts. By the way, I know that we say 2.5 hours is a lot of time, right? But a lot of us also are not able to focus for 2.5 hours. It's okay to take a couple of minutes break in between, right? If you feel that your brain is not functioning, or like you are starting to just hallucinate, or you're just generally not able to generate any ideas, just go to the toilet and wash your face, get a breather, especially if you have spent 10 minutes, 15 minutes solving nothing and then you feel a bit depressed. Just go to the toilet, just sort of shake out everything before you come back and continue. Okay? Because hard to focus non-stop for 2.5 hours. Another thing that I'll just say is SMO is not like your school exams, especially if you are newer to Olympiads and you're doing SMO for the first time. Or even if you have done primary school Olympiads. SMO scores are pretty low for, let's say, the cutoffs, and yet those are not easy to get, right? For those of you who are coming in a bit later, I mentioned my estimated cutoffs. It's like 14 for round 2, 12 for silver, 10 for bronze, 8 for honorable mention. It's not a lot. Like, if I were to tell you today that you can do 8 questions in 2.5 hours and get an award, that doesn't sound like much, does it? It's partially because we are used to school exams for math being pretty easy. And so, like, when you are doing the problems, like, what's the difference between if I solve like 9 out of 25 and 11 out of 25? They're both equally bad. No, they're not equally bad. There can be a very big difference. So do not give up, even if you feel that you're not making a lot of progress. But that's it. Just give yourself a breather before you carry on. All right, so pep talk over. Let's go through question 6 to 10 in the next 20 minutes or so. Question 6 is possible to be done in a couple of different ways. The so-called uglier way is to solve the quadratic and then after that substitute it. But that is called the uglier way because there is a much nicer way. And the much nicer way is just to use that x minus 20 and 26 minus x are repeating like this. So just do that. When I say just do that, for algebra in SMO Junior, one of the go-to things is substitution. If you see that something keeps on appearing, or if it's just otherwise ugly in some way, like in question 4, call them A and B. So by doing that, you end up with AB equals to 3. But of course, when you do the substitution, you also know that you have to see whether the A and B are related or not. Right? So if they are related here, the relation is that A plus B equals to 6. Then you can just use this to get A to the 4 plus B to the 4, right? Which is what I'm going to show. If you are in your mind thinking that SMO answers are all whole numbers, correct? That does not mean SMO questions all the x, y, and z are whole numbers. The final answer is a whole number, does not mean the x is a whole number. Okay, so don't try to factorize 3 and say, how come these two things can multiply to 3? It doesn't say x is a whole number, and you should not assume that the things in the question are whole numbers. If it happens to be, then great, but do not assume and say that the question has a mistake. So the way that we do this, power 4 comes from the usual square and square again. So square this one, take away the 2ab, and then square again. So a squared b squared is 2 times 3 squared is 18. So a4 plus b4 is 882. Okay, question 7. The length of each side of a triangle is a distinct prime number. The perimeter is 69 centimeters. What is the length of the shorter side? This does not sound like a lot of information, right? Because how can what is so difficult rather of having 3 prime numbers add up to 69? Not very much. If that happens, there are going to be a couple of possibilities. Right? The first possibility is maybe it's just a coincidence that the number 69 is small enough that the length of the shorter side is fixed even though there's quite a few triangles. Right? That could be one possibility. The other, which is the case here, is that you are forgetting that there is actually more of a restriction than initially appears. And so the second restriction is the triangle inequality. The triangle inequality tells you that the two shorter sides add up to more than the longest side, which you can also equivalently say that the longest side will be less than half the perimeter. Right, that's the same meaning. It's not the only thing, but it allows you to just begin looking. Because if the longest side is less than this, which is 34.5, but at the same time, it's the longest side. So the longest side must be more than the average length. There's not a lot of prime numbers between 23 and 34.5, is there? So you just do a quick check of all the numbers in between, and the only prime numbers that fit are 29 and 31. So we can try both. If it is 29, and then the other two have to sum up to 40, distinct prime numbers, and this is the longest side, means that you go down from 29 again. We know that the next one available was 23. We have already counted that. And you will already see that, oh, actually this seems to work, which it does. You will see that, well, there's no more space for this case. And if you were to try 31, where the other two add up to 38, there is basically nothing in between that is going to work. Remember that the side lengths are distinct. Distinct meaning different. So you cannot have 31, 19, and 19. That is not allowed. Okay, so therefore the answer is just 17. Okay, question 8. Now, this is the kind of question that is not supposed to be very difficult to eventually do. Some of you were a little bit concerned, and therefore you skipped the question because it's like, I don't know what equation to form. Well, here is where you use the fact that the SMO answers are all at most 5 digits, which means that I can just look at the number of digits and it is like, do I stop at a 2-digit number, 3-digit number, 4-digit number, 5-digit number? I should be able to get to my answer at one of those stages. So when you think of a method to solve a question, right, it's sort of like, I decide on the method because the worst case of this method is not so bad. It may turn out that the method works faster than that, but before you do the method, you won't know, right? So it's okay. Just think about like, what is the worst case scenario of that approach? So clearly, you know that with 26%, it's not going to be n is too small because 26% is also 13 over 50. Therefore, if 26% is 13 over 50, n is a multiple of 50. Or another way of saying is just that this is the number of things that have first digit 1. Now, we know that from 1 to 100, meaning that all the way to your start of the 3 digits, there's not that many things yet, right? So you have got 1 itself, one number. Then you have got 10 to 19. That's 10 numbers starting with 1. We know that it is not going to be even 13 yet. So my first thing is that, okay, let's try n equals to 150, 100, 150, and see whether those work. And if you try n equals to 100, of course, there will only be 12 numbers. If n is 150, you have added in another 50 more numbers. That is too much. So if you then reach 200 or more, the number of ones is going to stay stagnant for quite a while. Right? The number of ones is going to stay fixed at the 111 ones. Which is certainly not a multiple of 13 at all. So all of these are not going to work. The next batch is when you hit 1000 and now you're going to get some ones again. So for n equals to 1000, of course 112 is not correct. But for each subsequent number for quite a while, you are going to have all of them start with 1. So is it possible that I can have for the range of 1000 to 2000, I can find a solution? Well, we can check that. Okay, hang on. I think the lag is a bit too much, as I have mentioned. This does happen. So 1000 plus x over, sorry, not over, 1000 plus x, and I've got 112 plus x out of that is equal to 13 over 50. So this you can solve, and you'll find that it is going to be x equals to 200. And so n would be equal to 1200. Okay, so give me a minute before we continue, just so that like right now my voice and my writing are not synchronizing at all, and I think that may be a bit jarring. So let's just give me a second so that we can get things to be a bit neater. Okay, good. I think that is better. So just refresh the page. Okay, question 9. Question 9 is one that sounds very simple and perhaps is not very difficult, but infuriated some of you to no end because of the fact that like the number of cases with digits is just going to be too much. So this is where I would like to upgrade our understanding of divisibility test a little bit using a little modular arithmetic. Now, your test for 9, you have traditionally thought of it as just the sum of digits, which is correct, right? The sum of digits is divisible by 9. I think we would actually rather not have it be so limited to this and just change it to the sum of blocks is divisible by 9. The reason why I can say that and the reason why I want to say that are both pretty important. Now, why I want to say that is, let's say if I chop it up like this, wouldn't it be better to say 20 plus ABC plus 26 is divisible by 9? So that I'm now just picking a 3-digit number rather than picking A, B, and C separately. Now, the reason as for why we can do this is as follows. If we were to write it as just 20 times 10 to the 5 plus ABC times 10 squared plus 26, modulo 9, your 10 becomes what? Right? And so therefore, you are in fact allowed to do this. This is a lot better because then if this is supposed to be congruent to 0, 20 plus 26 is 46. It means that 46 is 1. So this is 0 mod 9, meaning that ABC plus 1 is a multiple of 9. And immediately you can just grab all of them like this. Just literally starting from 8 all the way to 998. Now, plus 1, right? I got a lot of different answers for this question. And so I can only conclude that if I see something like 74, 83, 101, 124, 136, if I get all of these kinds of things, I have no idea where they come from, right? I can only assume that it must be because you were trying to list out things where the digit sum is correct and then just messed up in different ways. If you did it by digit sum, you won't be wrong if you do all the cases correctly, but it is very easy to mess up. So this is actually what I was intending. Okay. Last one, question 10, before we take our break, is another one that everybody who did the question basically got it right, because it is quite hard to get the wrong answer. The entire logic is just this. You are given a floor function. Floor of a over b is 24. Now, floor means round down to the nearest integer, meaning that this just tells you that a over b is between 24 and 25. Therefore, b is really tiny. Sorry, yeah, b is really tiny, but b squared is even more tiny relative to a squared, because if you were to square this, it means that your b squared is roughly going to be 600 times smaller than a squared. Equivalently, what I can say is that this is the range that a squared is in, and so therefore a squared plus b squared is between this and this. And therefore, b squared, since this is 98765, is between this over 626 and this over 577. Now, you don't actually need to divide this thing here perfectly, because the entire point is that b squared is a square number. Right? So I just need to get a rough estimate. I don't even need to like worry about my perfect writing it as a mixed number. No need. So I can just give a very crude estimate and say that this is more than 150. This is less than 190. Let's say that's just my crude estimate. And already I know that the only square number in between is 169. So b equals to 13. Now, of course, an alternative way you can do this is just to say, oh, since b is tiny, just make a squared as close as possible to 98765, and then just sort of like get some nearby square numbers and check. Like, oh, okay, so 300 squared is 90,000, 310 squared is 96100. Oh, pretty close already. And then after that, you're like, okay, 315 squared is a bit too big. And then, just adjust until you can find the one that works. And then after you're like, okay, this one just fits. And then that is 169. So you can also do something like this and then just confirm that this is really equal to 24, which it is. Basically, your floor function can do a lot of things, but floor just means rounding. So effectively, it is just telling you a over b is roughly around there. So just use the roughly around there to do an estimation in one of two possible ways. Okay, so as promised, we'll take a break after 10. So we'll take a break here, and then we come back. I'll move a bit faster. If you're able to do 10 questions like this, you are basically at the level of a bronze already. So we are doing okay, but many of the harder questions, of course, will come in the next section. In the meantime, if you have any questions, let me know in the chat. I'll go off camera for a few minutes just to get a drink of water. If you have anything, just feel free to write it in the chat. Okay, so let's resume on the next. I think we will do maybe up to question 17 or 18 in the second block, and then we'll finish off in the third block. The first block, we had our intro and also questions 1 to 10. That sort of is the priority of those of you who are aiming up to a bronze or silver. I'm not saying that those of you who are aiming to get bronze or silver should only do the first 10 questions. What I'm saying is that I also explained it at a more slow pace, in the sense that if you're aiming to get a bronze or silver, you don't really need to rush at all. So you can afford to go at that pace or even slower, and that would be perfectly fine. I will now probably speed up a little bit as we talk about the middle section. The middle section kind of is more relevant to those of you who are hoping to get into round 2. You will need to be able to do a fair number of questions in the middle. We'll start with question 11 as a geometry problem has shown up. A couple of things that I need to address about geometry questions. Number 1, are the diagrams to scale? Answer is usually no, but there is nothing wrong with you grabbing a ruler and just seeing if the diagram is to scale. Number 2 is, what are you allowed to bring into the SMO? The answer is you can bring in a ruler, you can bring in a compass to draw circles if that's ever needed, but usually don't need for junior. Protractors are a big question mark. It is not in the official rules. And if you bring a protractor and your teacher doesn't say anything, it means that it is allowed. If your some years the SMS will tell all the schools to tell their students not to bring in a protractor. It seems to be a bit inconsistent. So bring a protractor, but don't expect that the diagrams are to scale. Don't expect that the question will be just something that you can do by accurate drawing all the time. Now, having said that, this diagram is quite accurate, which means that it is entirely reasonable for you to just measure and make a guess and see that AB is roughly 2 times of EF and say that AB equals to 40, and that is actually correct. It is, of course, not the intention. So let me explain how it is meant to be done. The question marks out a whole bunch of 90 degrees, and there are 2 lengths as well as a midpoint. Remember this pattern, which is that when you have a right angled triangle and then you have the midpoint, like this. Because what happens is that these 3 lengths will be equal. This is known as Thales' theorem. Right angled triangle and midpoint. Simple way of remembering it, either that this is actually just angle in a semicircle, which some of you have heard, or it's just half of a rectangle even. Right? If you just reflect it around, then this would be a rectangle, so that's why those 3 are equal. So that's the first thing you're supposed to do, is to realize that these are actually going to be equal to Z. The second thing, which you are meant to realize, is therefore that this is isosceles, and that implies that you have similar triangles. DEF is similar to triangle CAB by AA similarity, since you now have a right angle and a second pair of equal angles. Therefore, AB to EF is equal to AC over DE equals to 2. So indeed, AB is really equal to 40. I've said this a lot in my lessons, to the point of, I think, annoying some of you. Whenever you cannot solve a geometry question, what are the reasons? Apart from geometry is too hard, I don't like this kind of questions. The practical issue is often either you didn't form an equation that you were supposed to form, or you didn't spot similar triangles. When you have a lot of right angles, don't just think of Pythagoras. You often get similar triangles also, because AA similarity, you're already halfway there. You already got one angle. So the moment any other angle repeats, you are essentially almost guaranteed that there are more similar triangles, and then more equal ratios will allow you to move your lengths around. Okay, question 12. This is one of the most annoying ones. It is one of the most annoying ones in the sense that I can see some of you took 5 attempts in your submission before you got the correct answer, right? The correct answer, to put some of you out of your misery, is 6,720, which is a lot because there are quite a lot of different possible values of x. This is our problem. I'm definitely going to skip in the SMO at first, because even just looking at it, I'm like, ugh, annoying. Very annoying. Because why? If let's say that I let x be just the 3 digits ABC, there are 3 factorial different orderings of the digits, right? So it means that there are technically 5 cases. Now, you hope that the person setting the question is sane enough, i.e., I am sane enough, that I am not making you consider 5 separate cases that all have to list out a bunch of things. And yes, even I don't feel like doing that. This is going to fail because the A's will cancel off. You can of course write this as 100A plus 10B plus C, 100A plus 10C plus B, and so on. So I'll just write it in this way, right? This is 9B minus C, which is definitely never going to be 2, 3, 4. And this one, you're going to end up with the C cancels off. It is a multiple of 19, which definitely doesn't work. And of course, the reason for this not working is that the digit overlaps. So one more case where the digit overlaps is the middle digit B. That one will give you a multiple of 99, which also fails. So at least by just looking at these ones that have one overlapping digit, you already know that 3 of them are going to be junked. So 3 of them are going to be junked. You now have 2 cases. The 2 cases are where all the solutions come from. Okay, so that's what we're going to handle. The first one is like this, and I can cancel off a 9. Now, this 10B plus C, I can basically glue it back together again into the 2-digit number. And so effectively, what happens is that my ABC They're all non-zero and distinct, so you do need to list, but you're just basically saying, let me just list out all the A's and then just write down 11A minus 26. So 33 minus 26 is 7, is too small. You start with 44 minus 26 is 18. Then every time when you increase by 1 on A, you're actually increasing both B and C. Right? So it's just like this. If you increase it here, it became 640, which doesn't work, but then after that, the next three are going to be fine. So second case is if you have ABC minus CAB. This gives you, after you divide by 9, almost the same thing. So again, you can just list out the values of C. Starting from C equals to 1. The next one will be 704, which doesn't work. Now, at this point, of course, you can very begrudgingly add everything together. Alternatively, you realize that actually, because of the fact that we are just moving up by 111 each time, you can pair up these numbers in doing your sum. Because each pair adds up to the same thing, right? You just go up and down by 111. So there are 5 pairs that add up to just whichever one you want to use as a representative will be fine. So that's why this sum is also not as infuriating as it seems to be like. Okay, question 13. A fence is in the shape of a regular 13-sided polygon. Okay, the moment you read this, just pause and what do we know about 13-sided polygons? Do we even know what they are called? Go and Google it or ask ChatGPT what it's called. I forgot. But the point is that is so random that you know that it probably isn't too important. So each side has length 4 meters, and then a guard dog is chained to the exterior via a 2-meter rope. The region accessible by the dog has an outer perimeter of A plus B pi meters. Perimeter, not area. I don't know how to get the area of a 13-sided polygon. So perimeter, where A, B are positive integers, find tan A plus B. This is a situation where I don't need to draw everything. I'll just draw one section of it. I know that for a 13-sided polygon, the angles are going to be pretty big. I also don't really think I care exactly what they are. So I'll just draw one section of it, right, which is just 3 sides of it there. Now, someone asked in the comments, what is the meaning of the dog is chained to the exterior via a rope? Like, where is it chained to? Well, the bracketed comment just sort of already implies that it can reach any point at most 2 meters away from the fence, not away from its location of a chain, because the chain is just like you can just move around the fence. So therefore, it means that, for example, I will be able to start here and go 2 meters away. And then from this side, I can also go up to 2 meters away. and so on across the whole thing. Remember, we are not actually looking for the area, we're looking for the outer perimeter. So the important thing is that, yes, the outer perimeter will contain all of these kinds of things, but what is going to join them together? Well, the answer is that it is going to be joined, and although my drawing is not going to be very precise, it's going to be joined by what are actually going to be arcs with radius 2. Now, you could go and calculate that angle, and that is not wrong, but the key insight is that, well, these arcs, you basically are going rotate a bit, then straight line, rotate a bit, and then straight line, and you're going around a polygon, right? So your arcs should just sum to one circle. And that allows you to immediately say that it is 4 times 13 plus 2 pi r, where r is 2. Okay, and answer is 524. Okay, question 14 is another annoying sounding counting question. And once again, lots and lots of incorrect answers. The correct answer is 32. Do I list 32? Probably it can be done, but based on the answers I got, it is very easy to mess up one of the counts. So let me show you how you can expedite the count. The way that you can expedite the count is that, well, firstly, I will split into the upward facing and the downward facing ones, right? Because you know that triangles here can point in both ways. That's already, I think, something that a few of you may have forgotten. You only counted one of the directions. Now, the upward facing one has a trick. This trick is analogous to the counting rectangles trick, where we say that counting rectangles just have 2 vertical lines and 2 horizontal lines. So if you want to count, just count how many ways to choose those. Well, I can also do the same thing here. I can say that in order for my upward facing triangle to contain it, I'm going to need my lines of the triangles to be one of each of these. Right? Because I need to make sure that my triangle ends in those directions with respect to the shaded triangle. And obviously, if I pick one red, one green, and one yellow triangle among these, sorry, one red, one green, and one yellow line among these, you will form a triangle. So that case just is 4 times 3 times 2 is 24 already. For The downward facing ones, the idea is then that you technically only can work in this part. Sorry, not straightening the lines for me now. Let's try again. You can only work in this part. But wait, if you count that way, you will still miss some others because you can do things like, let's say, it comes out here and all. So if you use this approach, you will miss a few. The upward and downward, unfortunately, don't work the same way. If you were to count within this range, you can use that idea, but you'll miss a few. So this is probably best done just by listing out because the downward ones are much fewer than the upward ones since they will easily just go out of range. Okay, so I'll just count manually that for, let's say, the length 1, there's just 1. For the length 2, there are 3, meaning down here, down here, down here, and then you can count the size 3 and the size 4 as well on your own. Three and size 4 is that one that I outlined just now. There is 1. Okay, so I think that's probably just the best way to count the downward facing ones, is just to do it literally. And so when you add them up, that's how you end up with 32. Question 15 is an easy question in a sense, but with just one very specific trap. There are problems which have like very so-called subtle tricks, and then there are problems which just are like there is one and only one thing that I think will go wrong, and indeed about 1/3 of you who tried the question make the exact same mistake. So a sequence of 10 terms has first term equal to 1 and each term x. The next term is either equal to 5x minus 3 or 3x plus 11. How many possible sequences are there? Well, I have 2 choices each time. So is it just 2 to the 9? At this point, not sure. It may be, it will be 2 to the 9 if always there are 2 different choices, which I don't actually know whether 5x minus 3 and 3x plus 11 will ever clash. Right? Because 5x minus 3 equals to 3x plus 11 would be when x is equal to 7. So which means that if x is equal to 7, and only when x equals to 7, this shrinks down to one choice. But all other times, you do really have 2 different choices. Now, I also know that my terms are getting bigger, so I can just sort of draw a bit of a mini tree diagram just to see what happens. Okay, so first term is what? The second term is either 2 or 14. Okay, so 14 already past 7, don't need to worry. 2 is then going to go to 5 times 2 minus 3 is 7. So that is where I have a realization that, oh, so in this one branch, 7 will only have one choice down there, and the one choice it has is to go to 32. That is the only time where there's only one choice. In all other situations, there are always 2 choices. Okay, so how does that count? That tells me that, okay, if I went downwards to the 14, after that, I now have 2 to the 8 choices. If I went to 2 and then to 17, I have 2 to the 7 choices. If I went to the 2, then to the 7, and then forced to go to 32, I have 2 to the 6 choices. So I add up those things, and that is how I actually end up with the correct answer, which is 448. So one very specific trick, and the very specific trick is simply that I am going to have to watch out when it isn't really two different choices. Now, this is something for counting. Whenever we just multiply and whenever we just add, make sure there are no exceptions. If there's even one exception, then the answer would be incorrect. Okay, so this is now at question 15, which is back to the, I told you that I shall just take it off screen for a second so that I can refresh Microsoft Word for anti-lag measures. Okay. 60. Suppose that a equals to 4m to the 5 equals to 6n to the 7, where a, m, n are positive integers. Let k be the number of positive integer factors of a. What is the smallest possible value of k? This is a number theory question. The number theory question is that you have a list of things that are all integers, not just real numbers. When you have a number theory question, then the things that you have available to you includes things like your odd and even, it includes your prime factorization, which is what we care about here when counting factors. Now, I can see that 4m to the 5 and 6n to the 7, 4 is 2 squared, 6 is 2 times 3. So really, what I shall do, okay, I'll divide by 2 first, is that m and n should just contain 2 and 3s to balance each other out. In order to balance each other out, so that the a is as small as possible, there is no good reason to add in other prime factors into the picture, right? Because currently, why would I, let's say, make m and n multiples of 5? There's no good reason to do that. So I will just give them names. I will call it P and Q here. I will call them X and Y here, and just substitute them into this. So that's what I'm trying to do. And now what happens is that the 5p plus 1 should match with 7x. 5q should match with 7y plus 1. You want the smallest, and everything here is whole number, so you can just list. If you just list, you'll be like, oh, so I should just make p equals to 4, x equals to 3, right? 21. Here, multiple of 7 plus 1 is multiple of 5. I can just use 15. Now, don't forget that if you cancel off the 2 here, that A is still the 4m to the 5. So just make sure that you calculate the correct A when you put it back. So let's say I just use M. This is the factorization. And so the number of factors of A, we know the trick for counting factors is to take the exponents plus 1 and multiply them. So this is equal to 368. Yeah, apologies, I missed a couple of the messages in the chat. Probably deal with it during the break later. So we'll just carry on first. Yeah, so for this one, at least, why are we writing it in this way? Because we know that there are no other prime factors that we will be interested in the smallest value of k, which means the smallest value of a. And therefore, what I'm trying to do is to solve for the exponents in the prime factorization of m and n. Okay, 17. The trick to 17 is just to expand everything. Now, there will be at least one such question in the SMO every time where the solution is almost like, wait, I just didn't think it was a good idea. You mean I'm just supposed to expand it? This is about the thing I said earlier, right? Willingness to make a giant mess, to bash, to brute force, but a reluctance. So the reluctance is good, but there should also be balance with, fine, I have got half an hour left. I don't know what to do. I haven't done this question yet. Just expand it and see what happens. Maybe something good will happen. Because why? X, Y, Z is buried inside these things after all. Now, do not try to factorize 2026, right? It's not a number theory question. What we just did is number theory. Here, these are real numbers. So do not try to... 2026, by the way, is just 2 times 1013. So you're not going to ever find X, Y, Z whole numbers that satisfy this. So don't try to factorize it. Instead, I will just expand, but I know that the expansion is going to look similar for all of these. Okay, so the first one, XYZ is the first term. Now I can have one of the 20s and two of the variables. So that will be 20 xy, xz, and yz. I can have two of the 20s and one variable. So 20 squared, which is 400. And then I can have 20, 20, 20, which is 20 cubed or 8,000. Because the nice thing is that it is quite clear that the other two will behave in essentially the same way, except that the numbers are different and there's no minuses. So I will write them down pretty quickly, and I'm sure that you can infer why it is going to be not that hard to do the next 2 times. Wait, change the order. So this is my my 3 equations, and the 3 equations are 3 unknowns. But the 3 unknowns are not x, y, and z. The 3 unknowns are these guys. So it is basically 3 simultaneous equations, which if I call them A, B, and C, remember, every time when we see something repeating a lot, just do a substitution. Then what I can do here is the usual, which is elimination and then find A, B, and C. Okay, so I will just do that procedure here since we are going through the questions to completion. But from here, I think most of you will know what to do. Right? So if you want to zone out for 30 seconds, you can. Okay, so I think I will try to make my life easier. I don't want to multiply these numbers too big, so I will just eliminate A first. I'll substitute back later. Okay. Okay, so divide. So this is where your time in the SMO sometimes is used, right? Like they are not going to spam you with questions that all are like this, but I think they have the right to at least put a few, right? I mean, in all fairness. Okay, so then after that, you just do continue again. I think I've probably messed up something already though, which I am not surprised if that has happened. Wait, let me just check whether I've got the numbers right. Okay, honestly, I am not entirely sure um, where the calculation error is. It is not calculation error. Oh, okay, sorry. Yeah, that is fine. I think I am. Okay, yeah, so C is 9. Okay, I thought for a while I got a non-integer value. Okay, so that's good. Disaster averted because I think my notes I wrote something wrong, but actually this is correct. Okay, so that is fine. Put it back in. So you see, actually this is normal. Like I'm live solving this, and even on my own question, calculation errors can confuse me or even the lack thereof. Okay, so b equals to negative 297, and then after that we just throw this back into one of the equations, and you will get a equals to 486. Okay. Okay, I think one more before we take our break. Actually, wait. Give me a sec. Question was removed, so let me just take back. Okay, so question 18. Question 18 is one of the funniest ones in terms of the answers that I got. The correct answer is 16. The correct answer is 16, and I think I got every single possible integer between like 10 to 20. A few of that is probably guessing, a few of that is probably misread the question, but some of it is genuinely because a question like this is sort of a sequel to the counting right triangles from earlier on. Very easy to mess up, very easy to be falsely confident in the right answer, very easy to be never confident even when you have the right answer. Okay, I'm going to just put in a 5x5 grid first so that we can work in the 5x5 grid. So in the question, you have got 25 students on the 5x5 grid, 25 locations. And then when a whistle blows, each student shifts an adjacent chair. And yes, that means that up to 4 students may end up on the same chair. Now, what is the largest possible number of empty chairs afterwards? Now, I guess this means that you are trying to vacate chairs, but the easier way to handle it is the fewest number of occupied chairs. And then after that, you subtract that from 25. Now, when you want to have the fewest number of occupied chairs, it means that you would do something like this. You'll say that, okay, for example, if I pick this chair, then it would satisfy these 4. And then let's say that if I pick this chair, it will satisfy, and then it's quite easy to experiment with it, but never really to be sure that your answer is correct. Now, I can just tell you what the example I have in mind is, which is that the chairs that I will use are going to be symmetrically located like this, except that because the guy in the middle still needs to go somewhere, so I will just pick one of the random 4 neighbors, like let's say this guy here. So this could be my possible way of getting the final occupied chairs, meaning that everyone moves to one of these chairs, which you can see that all the remaining squares, it is going to be next to one of these. So 9 is possible. Now, with just an eye on, again, a round 2 style proof, how would you prove that 9 is the best? The answer is just find 9 students that must end up on different chairs. Find 9 students that must end up on different chairs, and it will imply that you need at least 9 occupied chairs at the end. And so to do that, I can just sort of go like, okay, these 2 will end up on different chairs afterwards. Remember, if they swap also, they're still on different chairs. And then I just kind of like greedily go through it and say that look for any time where I know that this person definitely cannot end up on the same chair as whoever has come so far. And you will end up with these 9 students will occupy different chairs. So therefore, that's how you get 16. Now, these are the kinds of problems also that even though the proof is maybe not so obvious, try it, experiment with it. Take 10 minutes, 15 minutes if let's say that you have time at the end just to explore different cases until you're quite sure you got the best one. I always say that SMO round 2 is almost like the equivalent of a math lab. You know, you have got physics lab, chem lab, and bio labs. Round 2 is kind of like a math lab, and I know that sounds wrong, a mathematics lab, because you get to just explore and you know that no matter what you do, nothing is going to explode. If you are in round one and you are having a bit of time at the end and you have questions like this where you're not sure the answer is correct, use that time to go and experiment with this, right? Rather than to say that I cannot solve anything else. Okay, so this is intermission number 2. I will take a couple of minutes break. I will answer a couple of questions from the chat, and then we will finish off with the last 7 questions when we return. The last 7 are not necessarily going to take super long, so don't worry about it. Okay, so couple of things before we resume. Number one, again, yes, these questions on average will be more difficult than most of the recent years SMO Junior round ones. If you haven't already, and you are taking the SMO next week, just try to look at the last few years of the actual SMO papers, because that is obviously not going to be the same questions that repeat, right? Whatever they asked last year, they're not going to ask again this year, but it's sort of like going to be more likely to be the similar in difficulty. Now, having said that, the difficulty over the years, there are some years it suddenly goes up, some years it suddenly goes down. So do not assume anything. Whatever I have here would be definitely considered a difficult paper. That's why I say that the cutoff is 14, and for round two, and then 12, 10, and 8 for silver, bronze, and honorable mention as the estimates. That would be lower than, let's say, most of the years of the SMO in recent times. How do I avoid making silly mistakes is going to be hard to guarantee. Like I said, two tips. One is that as you are reading the question, just try to think about what are the possible things that could go wrong with my approach. The second is that for our worksheet at least, I think some of you would have tried to squish all your workings into the blank spaces. Please don't do that. Uh, on the actual day, you can bring back the question paper, okay? So you can bring back the question paper, write your answers on the question paper, so that after that, when I do the review, you can just check your score for the actual SMO that same evening. But don't go and try to fit all your workings to the question paper. Do it on rough paper. Take the rough paper and sort of at least like split it into 2, 3, 4, or 6 parts and number the questions for the workings that you are doing. So that if you get stuck halfway, you can find your workings back. You don't misread due to bad handwriting or lack of space. You can always just like chop it up into 4 straight away on each side when you get the rough paper, and then just number the questions. If you don't want to do them in order, it's okay to just either just skip that space, or you can still split it like this and then continue somewhere else. Your school will give you the rough paper. You can ask for more paper, they will supply it. So please make use of the extra paper to make sure you can read your own workings, you can find them, and you can check them later. Okay, so now for the questions. Question 19, you have right angled triangles, which are marked out. You have these two are 12. Now you have similar isosceles triangles. Now similar is not an adjective. Similar literally means that they are similar triangles, which if they're not similar, uh, I mean, can I actually find the angle? No, actually I cannot find the angle if they're not similar. So it has to literally mean that. So similar isosceles triangles are constructed and their total area is 24 root 3. You're asked to find angle EAF, and it does look like EAF is almost like 180 degrees. It is not 180 degrees. Earlier we had a diagram that was kind of almost drawn to scale, right? Do not assume the diagrams are drawn to scale. It's just that if everything in the question looks kind of accurate, then maybe. But here I don't see any reason why the 24 root 3 is an accurate area. Like at least I can't even tell. So don't assume. Okay, so what do I do? First of all, what I can say is that this is not very important, right? This 12 and 12 just gives me 12 root 2 by Pythagoras. Other than that, the triangle itself, not very important, right? I don't use point D at all for anything else. So I can kind of ignore the big triangle down there. Now, what I am more interested in is this. Can I get the areas of these triangles and use Pythagoras on ABC to relate it in some way? I know the area is half times base times height, so it makes sense to draw the heights of both of these. And since they're isosceles, when you draw the height down by symmetry, they will be midpoints. So I'll just call these points here M and N. Now, I know that if the areas of the two triangles AEC and ABF are 24√3, then it means that your two triangles, I can just focus on these two. Those are going to sum to 12√3. Square brackets means area, okay? Now, I also know that basically the whole question is getting me to find this angle, which means that if I know this angle, then whether you think of a bit of trigonometry or even put trigonometry aside, just knowing that this angle has to do with the ratio. So I'm going to just again call these things x and y, and then I'll call this rx and ry because it's the same ratio. They are similar triangles. So on one hand, Pythagoras tells me that x squared plus y squared is 12√2 squared, which is 288. And, oops, sorry, no, 2x squared and 2y squared, yes? That is summing to 288. Which means that x squared plus y squared is 72. On the other hand, now if I use these areas, the areas of AEN and AMF is half rx squared plus half ry squared equals to 12√3, which means that half r times x squared plus y squared is 12√3. And so that means that r is equal to √3/2. Now, special triangles that we should know are the 30, 60, 90 and the 45, 45, 90 triangles. Right? The special triangle with the √3:2 ratio sorry, my bad. Yeah, 1/√3, yes, thank you. That is yeah, so the 1:√3 ratio is when you have a 30, 60, 90 triangle, because this is actually just half of an equilateral triangle. So by Pythagoras, the ratio is 1:√3. So the implication is that because this ratio is 1:√3, that means that the angle here is 30 degrees. And so therefore your angle EAF is 30, 30 and 90 is 150. So you don't need trigonometry for SMO Junior, but if you know trigonometry, by all means use it. If you don't know trigonometry, then at least know this 30, 60, 90 triangle and the ratio of the side lengths, because it's half of an equilateral triangle. And this one is part of what the SMO asks pretty often. Okay, I think we're definitely going to overrun 12 a bit, so I should try to move a bit faster. Okay, question 20. Let Sn be the sum of digits of any positive integer n. How many 4-digit numbers satisfy Sn is greater than S2026? Of course, S2026 is just 10. So I am simply asking you, how many 4-digit numbers have digit sum that is more than 10, which is a pretty difficult sounding task because that's a lot. Okay, 10, however, is very deliberately chosen because it is quite easy to count the number of 4-digit numbers whose digit sum is 10. Right? So it's at most 10. And let me explain why. Now, this is the classic stars and bars logic or partitioning logic, which is that 4-digit numbers with digit sum at most 10. If I were to call the 4-digit numbers A, B, C, D, A cannot be 0. It's the first digit of the number. So I can take away 1, where now your A minus 1, B, C, and D are all at most 9. Right? They are digits. This is basically your partitioning because I am now partitioning at most 9 objects into 4 boxes. The 9 objects are literally 9 ones that you're distributing to these 4 digits. Now, at most 9 objects into 4 boxes is the same as if what do I do with the rest of them? If I don't use 9, I put it into a 5th box. And so 9 objects into 5 boxes is then going to be the same as if I arrange 9 zeros and 5 ones. If you're not familiar with how this partitioning thing works, I think I talked about it in the video introducing some of the junior formulas a month ago. You can go and check that out. Okay, so arrange this in a row, which gives you 14 choose 5 ways of doing that. Okay, no, 4 ones, yes. 5 boxes means 4 partitions, so 4 ones and 13 choose 4. Okay, almost said the wrong thing. Okay, and so this is 750. So therefore, you subtract off. But unfortunately, this turns out to have one final nasty trap, which around an equal number of people submitted 8285, and the actual answer, which is 8286, because one of the cases here corresponds to the case where A minus 1 is 9. Because my 4 things are here. And that is, of course, A equals to 10, which doesn't work. So therefore, there's actually only 714. And so you need to correct this. And the correct answer is actually 8286, which I see a lot of people resubmitting on the second attempt after they realize that something went wrong. Question 21. This is actually there for a simple reason, which is that it's actually quite an easy question. It's a question that the spirit of it, I first saw it in the APMOPS, which is probably just about ending now in Hwa Chong. So I first saw this there. I just decided to kind of style it in a funny way because we are very used to the partial fraction version of the question, which is when this is multiplication, right? And then everything cancels off. And based on the answers that I got, some of you in your brain, you just auto-complete and you just like, oh, so this is equal to 1/2, this minus this, plus this, minus, sorry, this is plus, this is not times. So I think some of you auto-completed it because too used to that version of the question. This is meant to be easy, but the way I've written it does have, of course, that trap where if you are just not noticing it properly, then you just solve completely the wrong thing. When I ask you to find the floor, remember, same as earlier on the question number 8 with the floor A over B, you are basically just trying to approximate. So it just means estimate, well, estimate 1 over S because S is really tiny. Now, there is no reason to keep it that way. You can just open it up like this. And so therefore, if I want to estimate S, there are a total of 49 fractions here. A very crude estimate would be that it's between 49 times of the biggest and the smallest ones. So the biggest fraction is the first, the smallest fraction is the last. So it is between 49 of the smallest and 49 of the biggest. You can multiply both sides by 8, since also that is kind of suggested to be what is going on. And then just reciprocal it to get 1 over 8s. So in reality, this is not like a really good or really bad estimate. The estimate is here, it's 5 and 11 over 98. This is 5 and 59 over 98. So the error margin is about 1/2, which is mid, but it is good enough for us to be able to get the floor, which is often all that we need to do, right? When you have a floor, which means round it down to the integer value, you really just need to get it within a range of 1. So a range of 1/2 is actually more than enough for our purposes. And so also this question is a relatively easy one for the back section. SMO doesn't promise to put the questions in order of difficulty. I said this at the start. So let's say if you have seen this from old SMOs or you've seen this from like APM or PS or something, it's like, hey, this doesn't look very difficult. You're right, don't assume that the questions behind are all going to be impossibly hard. Okay, 22. Blah, 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 blah. There are basically 3 types of instruments, and you have to read very carefully to make sure that you don't accidentally assume that, oh, it's like, how come half the students play a wind instrument and then the ratio is 5 to 4 to 3? That's 1/3. It's because they play at least one type of instrument and some of them can play multiple. This can actually be borderline primary school Olympiad question also, but it is much more sneaky than the average primary school Olympiad question. So what I'm going to do is this. I'm going to say string, win, and brass. I'm going to let the number of players be 5x, 4x, and 3x. Now, the total is not 12x. The total is that half of them can play a wind instrument. So it's actually 2 times 4x equals to 8x. Remember that these do overlap. So now I need to form an equation. And this is basically the Venn diagram kind of logic. Let me make my circles so the Venn diagram not so ugly. If I take 5x plus 4x plus 3x, what I have done is that I have counted all of these string instruments, all of the wind instruments, and all of the brass instruments this many times. Now 8x is if I count each of them once. So therefore, in order to get the thing to be matching up with 8x, I need to minus off the 20. Minusing off the 20 will do this, this, and this. Take note, it is exactly 2 types that we have removed here. The 4 students there, you need to now not add it back and not subtract it once. You need to subtract it twice. Now, this is the key thing, right? Which means that based on the answers, many of you either didn't subtract it, or you subtracted it once, or you added it back, or you subtracted it 3 times. And all of them will give you a different wrong answer, which happens to be an integer, so you may not realize it has gone wrong. So take note that whenever you have these kinds of overlaps, up to 3 different categories, a Venn diagram is a good idea. You can just customize your inclusion, exclusion of like how many times you add and subtract to whatever the question gives you. Okay, 23. I would say that 23 is probably the hardest pure algebra question in this paper. It is not that it is a very long solution. It is just merely that, what do I do? Well, the answer to what do I do is that normally the minimum value of some quadratic-like thing. So this thing here is quadratic. So minimum value of some quadratic usually complete the square. But how to complete the square? Certainly not the whole thing is 1 square. Looking at this here, it seems that because there is x, y, and there is k. So the first thing that I am going to do is to try to complete the square using k stuff. Right? So I've got a lot of terms. There is the x, the y, and the k stuff. I'm going to just put the k stuff here. These are the two things that involve K, and then there's a whole bunch of other stuff behind. Now, to complete the square means that actually I factor out 3. And I'll be left with k squared y squared minus 2kxy. So it's just ky minus x whole thing squared. That will complete the square of the k portion. And it would leave me with a bunch of other stuff. So the bunch of other stuff, I am also going to complete the square. The x squared minus 10x, I can complete the square with x minus 5 squared. That uses up 25. The 2y squared plus 4y, I can complete the square with 2 times y plus 1 squared. And lo and behold, that swallows up the whole 27. So this is actually the intention. You complete the square in terms of x of k, and then you complete the square in terms of x and y. With that, you will end up with the conclusion that, oh, this is a sum of squares is equal to 0. So the equality case must be that x equals to 5 and y equals to minus 1, such that these two are 0. And that will immediately also imply, it's minus, right? Yeah, thank you. This is plus 1, correct? And then k equals to 5. So completing the square is normally how we will handle this sort of minimum value. And so it's just that I treat it as a 3-variable quadratic. So I deal with the k, the x, and the y. And from there, I realized that, oh, it's exactly a sum of squares. That's why k is uniquely equals to 5. Yeah, so the last few questions usually are the hard ones, yes. It is not perfect, as you can see that for something like 21 and 22, arguably there are much harder questions in front of it, right? But it should usually be the case. Right, question 24. This is sort of a weird sounding puzzle question. You have a 4x4 and you are supposed to not fill it up with 1 to 4 in every row, column, and box like a Sudoku. You are supposed to actually make sure that the stuff next to it, two of the things have the same number. Now, immediately, this will tell you something. The numbers in the corner only have 2 neighbors, right? So I can actually say that the numbers in the corners, let's say if the corner is A, these two will be A. So I'll just call them A, B, C, D, just so that we have a name. Not that the A, B, C, D are different, okay? A, B, C, D, we are not sure yet whether they are different. Now, the stuff in the middle, I don't know anything about them right now, so I will just call it PQRS so that we have a name for it again, and then we will decide what to do. Okay, so here are my options. Now, I know that the stuff in the middle must have 2 neighbors also equal to themselves. So that means that if, let's say, the P is the same as these two, meaning it is equal to A, if P is equal to A, then this 2 by 2 here is already going to have all of them be equal to each other and have two orthogonal neighbors that are equal. So none of the stuff around it can be A. That means that, oh, so how about this guy here? He's not A, so both of his neighbors must also be equal to itself. And so likewise for this whole thing, you can go in a loop. And this is case number one. Case number one is that they are just 4 2 by 2s in this way. Now, take note that when we have 4 2 by 2s, the 4 2 by 2s is not going to be just 4 factorial ways because A equals to C and B equals to D are still allowed. It's just that A and B are not the same, C and D are not the same, and so on. So I can say that there are, let's say, 4 choices for A. There are 3 choices for B. Now, I can say that there are 3 choices for C, but then, like we saw in the earlier sequence question, depending on what I choose C to be, D may have a different number of choices depending on whether A and C are the same. So I can say that actually is that if C is equal to A, then there are 3 choices. If C is not equal to A, then there are 2 choices for C and 2 choices for D. So this gives me 4 times 3 times 3 plus 2 times 2 is 84 grids that are made up of these 4 2 by 2s. That's not yet it, because this was assuming that the thing in the middle is matching with that. So we also have the other case, which is that, I'll just write it again so that we don't need to type it again. What if, let's say, this thing here was just not A, like it's something else? If it is not A, then its neighbors need to also be the same. Then the D and A must be the same, and so you just go around in a loop similarly, and you will find that the conclusion is actually that the whole outer perimeter is the same. And the 2 by 2, the 4 things in the middle are the same. This would just give you 4 choices for A times 3 choices for X. So this is the conclusion, that there are a total of 96 ways. Now, the thing about the counting questions, right, is that it is going to be that the solution is quite short, but it's very hard for you to know whether you have messed up. So all I can say is, if your answer is different and you don't know why it's wrong, there are just about 2 or 3 possible reasons, right? One is that you have included something illegal. 2 is that you have excluded something legal. And 3 is you have counted something legal more than once, right? That's sort of the potential things that can go wrong. One of those things must be wrong, and if your answer is smaller, it probably means that you missed something. If your answer is bigger, it probably means that you accidentally multiplied by more stuff and overcounted or included some things that are actually not allowed. Okay, so you can check on your own what exactly might have gone wrong. Now, last question. We are at the end of this HARDSMO. The answer to question 25 is 25. This is not telling you that you should guess the question number. This is just, I'm telling you it's 25. For everybody that guessed that the answer is 30, then you're like, huh? Wait, how can the answer be smaller than 30? Then after that, you think for a while, oh yeah, huh? Cubes can be negative. Actually, this question is quite easy to guess in a sense, but it has been counteracted by the fact that the two solutions are 30 and -5, right? Which means that if you were to just roughly guess, it's quite easy to miss out on the negative solution being a thing, right? Perfect cubes can include negative stuff. Yes, those are cube numbers. Just like I can say that negative numbers can still be even, right? There's not like even numbers must start from 2, 4, 6, 8, 10. Now I'm just going to explain the logic, but the logic of this is actually quite tricky. This is actually going to be like a round 2 style question in logic, but it is quite easy to guess as long as you were aware that negative numbers are a thing, which has been kind of telegraphed by the fact that I said sum of all integers, not positive integers, that kind of hints something. Okay, so my idea is just that I'm going to, for convenience, do a substitution of, I'll call this thing here m cubed. I want to understand why the second one is usually not going to be a cube if the first one is a cube, right? Because sum of all integers means that there is a limit. N is m cubed plus 3, so I'm going to just do this, and I will just expand. Now, why would this be a cube or not be a cube? I mean, looking at this, I have no idea whether that is a cube, right? How does this thing tell me that it is a cube or not a cube? Okay, simple explanation is that if you to see something that is too close to a cube number, it's probably not a cube number because cube numbers are very far apart, right? They grow very fast. That's except for the small values where they aren't growing so fast yet. So my reasoning is just going to be very simple. My reasoning is that usually it is going to be squeezed between two cubes. Now, usually it is going to get squeezed between two cubes, therefore it is not a cube. Now, the point is that I will leave you to check most of the technical algebra, but it's that if I just expand the m squared plus 1 cube, right, which is the more weird looking one, it has a 3m to the 4. This is power 4, that is power 3. That means that when m is big enough, this will really be true. Of course, when I say if m is large enough, this is true. It also is true that if m is negative, then the thing on the left side, 6m cubed plus 109 is going to be the wrong way. Well, for m negative, you can always flip around the other side. It will be sort of squeezed the other way. Again, usually. Now, the usually is how we handle a lot of Diophantine equations in both round 1 and round 2, which is that assuming that stuff are too big, they won't work. Therefore, I only need to list a few things. And I can say that based on these bounds, you can just check something like m is between -4 to 4 will be all you need to verify. Okay, so beyond this range, the inequality is true, so they all die. In this range, it doesn't mean they all work, but you can just check directly, and you'll see that m equals to -2 gives you the negative solution, and m equals to 3 gives you the positive solution. Okay, so and that is our hard SMO done. Hopefully for all of you guys, actual SMO will not be hard SMO. Actual SMO will be not so hard SMO. Again, for everyone who is just joining in, let me end on an important note. Do not assume that this is the difficulty of the SMO. It also is not a good idea to assume that the SMO will definitely be easier than this. It changes every year. It is just that if the SMO looks very difficult, every question really counts. So by all the various tricks that I've mentioned, try to squeeze out every one question and consider it a success. Every one question you solve is a success. It's not like school where if let's say you did one question right, that's not a success. You should be doing almost all of it right. On the other hand, if it turns out that the paper looks quite easy, like you flip to the back and say even question 21 to 25 don't seem very hard, then please do not aim to try to just score like 14 points is enough for round 2. If it looks that way, probably 14 points is not enough for round 2, right? All of you guys are pretty good, and therefore the cutoff scores are not going to be that low, right? Only about 100-ish qualifiers for round 2 across Sec 1 and Sec 2 means that you expect that it can be quite a challenge. Okay, so I think that is a good place to wrap. I will stay here for a few minutes if any of you have some more questions. But otherwise, all the best. And our review for the actual SMO will be at 7 p.m. on the day itself. I will be doing senior first so that all those doing senior can go to sleep at night to prepare for open if they're also doing it, right? So I'll do junior at 7 p.m. a bit later. So on that day, just write your answers on your question paper, which you're allowed to bring home. And then you get to find out a bit early what your score is and maybe mentally prepare whether you should be getting ready for round 2. Okay, so yeah, I will answer some things in the chat, but otherwise I will go off camera for a moment and I need to get ready for the senior stream as well. Mm-hmm. Okay, I think I need to answer a couple of things quickly. Yeah, for the counting questions, like I said earlier, you cannot really be 100% sure if it's listing based without proof, meaning that you know that you have covered all possible cases. Now, this is one of those things where how do you know you've covered all possible cases? There are many different types of scenarios, but basically it is that there are also many correct solutions. It's not how do you think of my correct solution. If you got your correct method, it will not miss anything. So just often test the weird cases. Like think of the weirdest example you can think of and see if you have counted it exactly once. In terms of the cutoffs wise, so the thing about cutoffs is that they do not actually have an official percentage for how many percent gets gold, silver, bronze, and honorable mention. It is not fixed anymore, which means that sometimes it could just be more because they were more generous that year. The benchmark though is kind of there, which is that if the average score goes up, then the cutoff scores will go up. But you're not looking at like maybe the average of everybody, because like, I mean, they're not giving awards to like 50% of people. So let's say the bottom 50% doesn't really affect the cutoff scores, if you are being honest. And likewise, also the top 30 people don't really affect the cutoffs for, let's say, round 2 or for silver, bronze, and all that. Right? So they have a rough guideline, I think. If there are many easy questions, then usually, of course, that will make all of it go up. But if there are many medium difficulty questions, it may cause the round 2 cutoff to go up, but the bronze and honorable mention cutoff may not go up. That is how it could be. Yeah, and for the last one, the -4 to 4 is just an example. I'm saying that you can just test those inequalities to see that beyond m equals to 4 or -4, that statement is true. Sorry, it's not on screen anymore, but basically beyond that point, it definitely is true that there are no cubes, therefore I only need to check the ones in the middle. It's not that -4 to 4 will work, right? That's just saying that let me find a benchmark where clearly it is going to no longer be true. Okay, so if you have any questions after this, I think you can leave it in the comment section of the replay, or if some of you joined late, then you can always watch it back and let me know. Apologies for a bit of lag. I haven't done live streaming for a year, and somehow my laptop doesn't like it very much. So I will get a bit of the settings sorted before my senior stream. But otherwise, again, thanks for coming, and all the best for actual SMO Junior Round 1 in a few days' time.